Now I'm going to solve from Blue Book for question number 490 about complex numbers. Here it is given alpha minus 1 plus minus I root 3 or root 3I. Prove that alpha square plus alpha plus 1 is equal to 0 and alpha cube is equal to 1. Determine the real number and imaginary part of the a alpha square plus b over a plus b alpha. This is the question. First, we are going to deal about the first part. We are going to prove the alpha square plus alpha plus 1 is equal to 0. And if you are familiar to complex number, you know that the quadratic equation x squared, the quadratic equation of this one, x squared plus x plus 1, or if I write here instead of that one, if we try to solve the root of equation alpha squared plus alpha plus 1 is equal to 0. This is quadratic equation like x squared plus x plus 1 is equal to 0. Then you cannot factorize this one. That's why you are going to use delta method for this one, which is equal to b squared minus 4ac, and delta is equal to here a, b, c, they are all equal to 1. 1 square minus 4 times 1 times 1 it's going to be. Then delta is equal to 1 minus 4. Delta is going to be equal to minus 3. And x1 and x2 is equal to minus b plus root, or x1 and x2, let's write minus b plus minus plus minus root delta over 2a, which is equal to minus 1 plus minus root of minus 3 over 2 it's going to be. And we are going to understand that it's equal to minus 1 plus minus root of minus, actually not minus 3 now, because I'm going to get rid of the minus inside the root with I. Then it's going to be minus 1 plus minus root of 3i over 2. So if the root of the equation is minus 1 plus, which is alpha here, which is the term here, actually I need to use here also alpha plus alpha 1 plus alpha 2. Okay, let me continue. Then if I find the roots of this equation, minus 1 plus minus root of 3i over 2, it means that these values are going to satisfy this equation, which means when you replace by one of them, it's going to give you 0, because the root means that one. Okay, so we prove that alpha squared plus alpha plus 1 is equal to 0. Or there is a second way. You may replace the with alpha by these terms, and you are going to see that the result is going to be equal to 0, but this is the second way I said. If I find alpha cube minus 1 is equal to 0, then I'll prove that alpha cube is equal to 1 if it is equal to 0. And now I'm going to look for this value. Why I'm going to look for this value? Because I know that a cube minus b cube is equal to a minus b times a square plus ab plus b square going to be. Then alpha cube minus 1 cube is equal to alpha minus 1 times alpha square plus alpha plus 1 it's going to be. And still I don't know what is the value of it. Then I'm understanding that alpha minus 1, here we don't know the value, but alpha square plus alpha plus 1 is equal to 0. Why? Because when you replace the alpha by minus 1 plus minus root 3i over 2, this value it becomes 0. So here if I say instead of this value, if I give this one, it means that alpha cube it's going to be alpha cube minus 1, it's going to be equal to alpha minus 1 times alpha square plus alpha plus 1. So this value is equal to 0. I know that one. And if it is equal to 0, alpha minus 1 times 0, it's going to be equal to 0. So it means that alpha cube minus 1 is equal to 0. It means that alpha cube is equal to 1 going to be. Again, I'm repeating this part. Here, alpha minus 1 times alpha square plus alpha plus 1 is the factorization of alpha cube minus 1 cube. Why I'm looking for alpha cube minus 1 cube? Because alpha cube is equal to, I'm going to prove that alpha cube is equal to 1. And instead of giving the alpha value here, instead of replacing that one, I'm using the a cube minus b cube formula. If I prove that alpha cube minus 1 cube is equal to 0, then I will say that alpha cube minus 1 is equal to 0, then alpha cube is equal to 1. And I made that one, alpha cube minus 1 cube is equal to alpha minus 1 times alpha square plus alpha plus 1. When alpha is equal to minus 1 plus I root 3 over 2, I knew that alpha square plus alpha plus 1 is equal to 0. So this value is going to be 0. If this value is equal to 0, this is completely 0. If this is completely 0, which means that alpha cube minus 1 is equal to 0. If alpha cube minus 1 is equal to 0, alpha cube it's going to be equal to 1. Now I'm going to determine the value of, this is the last part now, I'm going to determine the value of a alpha square plus b over a plus b alpha. For calculating this one, the tricky method is a alpha cube plus b over a plus b alpha is equal to question mark. Then for calculating this one, the tricky way, pardon, a alpha square it's written, a alpha cube I made that one, a alpha square plus b over a plus b alpha times alpha over alpha we are going to do here. Then this is going to be equal to a alpha cube, alpha times alpha square, it's going to be alpha cube plus b alpha all over a plus b alpha times alpha is going to be. Now I didn't multiply by this one because I knew that I'm going to find a plus b alpha, and a plus b alpha we are going to simplify because also it's written here a plus b alpha is not equal to 0. So I may easily simplify that one. A plus b, because why it is a plus b, I didn't explain this one. In the previous part I proved that alpha cube is equal to 1. So this is alpha times 1 plus b alpha all over a plus b alpha times alpha. Then upper part it's going to be equal to a plus b alpha all over a plus b alpha times alpha. It's going to be, when I simplify these two, here it's going to be 1, you know, that's equal to 1. The answer is going to be equal to 1 over alpha. So whole expression is equal to 1 over alpha. And for finding the 1 over alpha, I need to find what is 1 over alpha here now. For finding the 1 over alpha, I'm going to do here these operations now. What is 1 over alpha? Because this expression is equal to 1 over alpha. 1 over alpha is equal to 1 over, here alpha is equal to, I found that alpha is equal to minus 1 plus minus root 3i over 2. So it's equal to minus 1 plus minus root 3i over 2 it's going to be. Then if you send this term to upper part, it's going to be equal to 2 over minus 1 plus minus root 3i over 2. And this is irrational denominator, so this expression is equal to actually this one, but I need to, it says that find the real and imaginary part, determine the real imaginary part of the number a. So I need to rationalize the denominator. For rationalizing the complex denominator, I need to multiply by the conjugate. So I'm going to multiply the denominator by minus 1 minus plus root 3i. And you know the result of this one, this operation, minus 1 a plus bi times a minus bi a minus bi. When you multiply by the conjugate, the result is equal to a squared plus b squared. We know this. If we multiply by the conjugate, this is equal to 2 times 1 minus 1 plus minus root 3i all over. Minus 1 square, here I have written y minus 1 square plus root 3 square it is, because when you multiply by the conjugate, a plus bi is the complex number and a minus bi is the conjugate of it, the result is equal to a square plus b square. So for both of them we are multiplying by the conjugate, the result it's not going to change, it's going to be a square plus b square. So it's going to be equal to minus 2 plus 2 root 3i all over minus 1 square plus root 3 square, or I will write like this, and this is easier. 2 times minus 1 plus minus root 3i all over 4. When you simplify 2 and 4, it's going to be equal to minus 1 plus minus root 3i over 4. But we need the real and imaginary part of this expression. That's why it's going to be like minus 1 over 4 minus plus then root 3 over 4i. Real part is not going to change for both of the value because we have plus and minus signs. Here this is a alpha square plus b over a plus b alpha value actually, and here it is also a alpha square plus b over a plus b alpha, and this is equal to, at the end we found this one, it's equal to minus 1 over 4 plus minus plus root 3 over 4i, and real part is the minus 1 over 4, real part is the minus 1 over 4, and imaginary part is the plus minus root 3 over 4. It's going to be, this is the imaginary part of the question.